Welcome back to another episode of Ham Radio Playground. In today's episode, we are going to take a Raspberry Pi and a Baofeng UV-5R Mini, and we're going to make an APRS iGate. What do you need to get started? Well, obviously, a Raspberry Pi. We're going to be using the Pi 3 B+. Kind of overkill for it, but it's what I had laying around. I got several of them. Why not put one to use? Use what you have available to you. You could probably even get by with a Pi 0W. What else do you need? Obviously, a power supply to be able to power the Raspberry Pi, which is USB. You also will need a micro SD card, which chances are, if you got a Raspberry Pi, you've already got the micro SD card. So I'm using a 128 gig, which is way overkill. Ideally, you want something like 16 gig and above. That's what happened to be in this device. I do see on my desk, though, I've got a 64 gig one sitting here. Not sure what that came out of, but we're going to use 128 that's in it that I know is working. I don't want to overwrite the other one because I don't know what's on it. And then obviously you need a radio of your choice. In our video, we are going to use the UV-5R Mini. Why? Because I got one laying around. Well, I got two laying around, thanks to Radioddity. But essentially, you can swap out the radio in this guide for any radio of your choice. You'll just need to make sure you have the appropriate cables to connect. So let's talk about that piece right there. How do you make it connect? Well, you've got a couple different options for the audio interface. You'll be able to choose one of these. So if you have the right programming cable, you could use that. Now I have 1, 2, 3 different styles of programming cables. And guess what? None of them will work for this purpose. Why? Because they don't have the audio chipset in them. Typically, you'll pay a little bit more for a programming cable that would have the chipset inside for the audio abilities. So, take that out of the mix. What else can you use? Well, you can pick yourself up a USB sound card, something like this little guy right here. As you can see, it's just a USB port, and if I can hang on to it, it's got 2 little headphone jacks, right? One's audio in, one's audio out. So inside here is the chipset that similarly could be inside your programming cable. So, okay, I don't have one of those. What can I do? Well, you can get one of these pretty cheap and usually next day on Amazon, if not same day. Maybe you got a little Digirig or Digirig Mobile laying around, which essentially does the same thing. Interfaces to your computer with USB, if I can get the camera to focus on it, and then gives you 2 ports. Now, you need to be very selective on the ports. They are labeled audio and serial. You'll use the serial side to program your radio, the audio side for the sound card. You want to make sure that you are only using the one cable for the audio side to connect to your radio. When you get the cable set for your Digirig, they will be color-coded. One is black, the other is green. I don't know where the green one is. It was here a minute ago. I must have thrown it in the box I took off my desk. As you can see, the ports are also color-coded. Black and green. Where do you think the black cable goes? Into the green port? No! Into the black port. Makes a difference to what's being sent to the radio, how it's being sent to the radio, and how it's being processed. So black cable, black port, and then that would connect into your radio. Now, as you can see, all of these cables, the programming cables and this Digirig cable, are the Kenwood style jacks, because that is what the Baofeng needs. Okay, Kevin, I don't have a programming cable with the chipset. I don't have a USB sound card. I don't have a Digirig, but I happen to have a signal link laying around. That'll work too. You simply need something to interface with your radio to the device, which we're going to call it a computer, because essentially that's what a Raspberry Pi is a computer. What else might you need? Well, the little stock antenna might not cut it depending on where you're located. So you might need a bigger antenna. This happens to be an antenna that was sent to me with another radio. I'm going to use this in our demonstration. You can also use a larger outdoor antenna with the cabling coming in to your HT. You might want to use Ethernet to connect from your Raspberry Pi to your router or your internet connection, or however you get internet where you're at. For our demonstration, I will be using the Wi-Fi, which is okay. The Ethernet just happens to be a little bit more reliable. And then you need some kind of case to store your Pi in. As you can see, mine's already in a case. I can try to pop the lid off and show you the circuit board, but I'm sure you've seen a Pi in a million different videos. All right, so what do you say we get started with this and start working through? Would you like the step-by-step instructions for building this? Check the description down below. I'll give you a link where you can go download it. So APRS, what does an APRS iGate do? Well, an APRS iGate takes the packets being sent by radios that support APRS and sends them to the internet so that they'll show up on places like APRS Fi and other avenues. That telemetry data will then appear there. APRS is a packet reporting system that sends out location packets, and that's what a lot of people use it for. But there's some messaging involved and other aspects of it that gives another way to communicate should there be a situation that requires us to be a little more tactical. Other scenarios, you could take a little tiny device that supports APRS, like these UV-5R Minis, attach them to a backpack, and then be able to, track where somebody's at. Now, obviously, you'll need something tied to this that will give a GPS location. So maybe you go a little bit bigger and go with like the UV Pro that has GPS built in it, or you get a different radio that has GPS built in it. Or you could even build a little tracking device that, has a radio hat in it and GPS, and then reports back positioning. So you're going on a hike with a group of people. Somebody gets lost. Well, let's pull up the map and see where was their last location. All right, enough about that. Obviously, you're watching this video. You're familiar with APRS. You're interested in setting up an iGate, which takes those packets and send them to the internet. Now, in this demonstration, we are going to do a receive-only iGate. It's a perfect setup for beginners to get started. And at the end, I will show you how easy it is to take that receive-only and turn it into a digipeater that will then also transmit out the packets it receives and repeat them. Okay, so let's take a look at hardware setup. So first thing we need to do, we're going to configure our radio. So we're going to turn on our UV-5R, which mine's already on. You're going to want to set the channel to 144.390. Why? Because this is the standard APRS frequency in North America. You're going to want to go into the menu, and you're going to want to go to radio settings, and you want to go to number 2, which is squelch. And you're going to want to make sure that your squelch is set at level 1 or 2. You want a lower squelch to be able to catch some of those weaker packets. Oop. So I am going to go in here. No, I want radio settings, number 2 squelch, and I want my level at number 1. All right, confirmed. Thank you. You want to turn the volume about 50-60% on the dial. We'll adjust this a little bit later from now. Don't overstress it right now. And you want to make sure you've disabled any CTC, SS, or DCS tones. Wow, there is a packet coming in right now on APRS. I bet you it's my UV Pro that's in the other room near the window getting a GPS signal. It will transmit, and as you just heard, it sends a packet out and says, boop, here I am, here's my data. You'll also want to make sure that you're set to wide FM. or like a 25 kilohertz bandwidth on your radio. All right. Let's see. What is our next steps? Well, we got to choose our connection method. Are we going with the programming cable? Are we going with the Digirig? We're going with the signal link, or maybe even the USB sound card. They're all very similar. It's plug the device in, connect it to the radio. In our case, since I know none of my programming cables are going to work, let's get rid of those. We're going to use the Digirig. So first thing I need to do is I need to take my Digirig and plug in the audio cable. Remember, black to black. Then I'm going to take my jack. Oh, connect it to the Raspberry Pi. My Raspberry Pi is not even powered on right now because we still have to configure the software. We have to download and do all of that fun stuff. But we're going to go ahead and connect our USB cable. And yes, I know it's a white cable. Everything else is black. This drives me nuts. Don't worry about it. I got you. We do have black cables here. Right here on my desk, I had a white cable. So we're going to take that. We're going to plug it into any of the USB ports on our Raspberry Pi. Whoop, just like that. So while I'm here, I'm going to pull my SD card out. I'm going to throw that over here because in a minute, we are going to take care of that. Next step is we're going to take this and we're going to plug it into our radio. So you're going to want to go down here and you're going to open up the flap. I'm going to turn that volume down. We're going to open up the flap and you'll see that exposes our jacks. And we're going to take this end of the cable and we are just going to plug it in there nice and snugly. And you want to make sure you push all the way in and hear it and feel it click. Okay, boom. That is all set. Our radio is now connected to the Raspberry Pi. That's how easy that step is. So now that I have that plugged in, I can turn my volume back up to 50 to 60% because we're not going to hear it anymore. It's going out the cable. I'm going to take my radio, I'm going to put it aside. Initially, we're going to use the stock antenna, then we'll add this antenna afterwards. So, all right, next step. You need some kind of device that's going to connect to your computer that allows you to read and write to your little SD card. So I happen to have a little USB device. It came with something I purchased, I think one of the 3D printers or something else. So I'm going to use that. Your computer may have a slot that you slide it in, or you'll need an adapter card. You're going to do you. You're going to have some way that you can read and write to that SD card. So let me get that plugged into the computer. While that's doing that, we are going to go out to Raspberry Pi's website and download some software we need. So we're going to come over here. Let me get my keyboard in front of me. I can take the Pi, I can take the cable and move it forward, shift a few things around on the desk. So you can see the mess I'm working with today. All right, so we are going to go to Raspberry Pi. It's raspberrypi.com. And what we're going to be looking for is software. We want this Raspberry Pi Imager. It's going to make it really nice and easy to load this stuff onto our SD card. So we're going to say download. Maybe. Oh, it's going. Camera's right in front of the screen that I'm looking at, so I didn't see where it went. Yes, accept cookies. Is that done downloading? Yes, it is. All right, so I'm going to open the folder where it's at. And of course, that opened on the other screen. All right, so we're going to execute by double-clicking on the app. And you'll get this window that says, hey, are you sure you want to make changes to your device? You're going to say yes. And we can minimize this because we don't need that anymore. And of course, the installation wizard keeps popping up on the other screen. We are going to say, yes, I want English. Choose whatever language preference you have. We're going to next our way. Yes, I accept the agreement. Why? Because we don't have a choice. We want to use it. We have to accept it. If we say do not, it won't let us install. Default location is fine. No, I don't need a desktop icon. You may want a desktop icon. Just select that option. Me personally, nope. I like my desktop clean. The rest of my world is a mess. Why does my desktop need to be? Launch Raspberry Pi Imager. Yes, of course. Make it easy for me. You launched on the wrong screen. All right, so we have it over here. So I am going to give us a new tab, but close the Raspberry Pi out so we can bring our imager back. We will need the browser for a couple other pieces throughout this, but right now we don't. So choose my device. I have a Raspberry Pi 3. Obviously, you'll choose what you have. Choose our OS. Now, this is critical. We want to, as you notice in our instructions, we want Pi OS Lite 64. This gives us a headless operation, so it's command prompt only to get into it. You'll SSH into it to be able to access it. There is no Windows type environment. You know, this is a Linux-based machine. If you want the desktop or the Windows environment to be able to log into it and operate it, then you can choose the full Pi OS 64-bit. My demonstration for you here today will be command line only. So we're going to come down here and we're going to select Raspberry Pi Other, and we want Pi OS Lite 64-bit. So now it's going to say choose our storage. And we only have the one device that comes up, and that is the correct device. And then we're going to hit next. Now here is where we have the opportunity to make our life a lot easier. Because if you don't do these steps here, you may not be able to get into this device, and you'll have to go reflash this SD card to be able to put into your Pi. We're going to say edit settings. And we're going to set a host name. And we're going to call it APRS iGate. Set a username and password. This is if you don't want to use the default Pi username and password to get in. Oh, you guys almost got me again. Look at that. So now you guys know the first letter of my password. And we'll bring it back over here. And configure wireless LAN. This is critical so that if you're not connected via Ethernet and you're going Wi-Fi, pre-configure this because you will not be able to get in this device remotely. You'll have to hook a keyboard and a mouse and all of that fun stuff and a monitor to it in order to be able to log in and make these changes. Or the easier path, reflash the card and make sure you check these settings. So it already knows my Wi-Fi from my computer and it's pre-populating it here, which makes it easier. Now do not hit save, do not hit cancel. We're continuing to go down through this list. We need to set our Wi-Fi country. For those of you in the US, you obviously are going to pick US. If you are not in the US and you're following this tutorial, make sure you change your radio to the appropriate APRS frequency for your location. The one I gave you in the step was for North America. And we are almost there. US. All right. And I'm going to set my local settings to New York because that's where I'm at. My keyboard to US. Again, pick your locations. You don't have to choose mine unless you happen to live here in New York or on Eastern time. All right, so we want US. Now again, do not hit save yet. We're not done. We need to come over here. This is critical. Enable SSH. Use password authentication. If you really want to be super encryptive, you can do SSH keys. I am not going to teach you that here. That is not what this tutorial is on. But you can add a pre-shared key in here to be able to log in through keys, encrypted keys, instead of using a password. My device is behind a firewall. I'm not worried about somebody trying to hack it. And really, what are they going to get? Some APRS data? Woo. All right, we'll look at the Options tab. Eject media when finished. Enable telemetry. Play sound when finished. Those are all optional. You can choose which ones you want. Now we can hit that save button. We're going to go ahead and hit save. Now it's going to ask us, hey, do you want to apply these settings? We need to make sure we say yes. If you say no clear settings, you just wiped out everything we did. If you say no, it will not use those settings and just do a default install. We're going to say yes. Then we get a warning. All existing data on our card is going to be erased. Are we sure we want to continue? Yes, Kevin, we want to continue. Make sure you're not using a card. You've got valuable stuff that you don't want to destroy. Oh no, I just wiped out all of my crypto. I'm going to be broke. Hee. You're funny. So now we're going to wait for this process to finish. I'm not going to make you guys wait. I'm going to speed this up. All right, we're back. It's finished. Now, you may have a point where that verification cycle comes back and says that it failed. All you have to do is go through the options again, and it'll rewrite to the card. That occasionally does happen. It's not abnormal. So we're going to go ahead and say continue. We can now remove the SD card from the reader. We're going to pull our little device out. We can close that application because we no longer need it. We simply need our little card. Boop. We're going to plug this into the Raspberry Pi. Like so. All right, my card is in. Now, our next step is to power on our Raspberry Pi. Let me get the power cord. Too much stuff on my desk. Oh. Are you kidding me? Give me 1 second. I dropped the cord. All right, let's try this again without dropping the cord this time. We're going to take this and we're going to plug, and that's not the right cord. Son of a gun! Where is... Oh, I see it. It's still hanging down there. It's connected to the same block that this cord is. See if I can get it without breaking anything. Huh. There's a method to my madness somewhere, right? I can't tell if it's on or it's not on. Guess we'll find out in a second. So you typically want to give it a minute to boot up. If you changed your username and password, you're going to use the username you put, not Pi, in our documentation. So you're going to come out to Windows PowerShell. It should be installed by default on your computer. We're going to do SSH. And I gave it a username not using Pi. And we are going to say, if you did not change your device name, then you're going to use raspberrypi.local. We did change our device name. We're going to use APRS iGate. Local. And let's see if it's up. Could not resolve the name. So this could be two factors. One, the Pi is not up and running. I need to double check the cord to make sure that we're good and I didn't knock something out. Two, the name isn't being translated, which is okay. So there's a couple things you can do here. So real world scenario, I don't edit this out. I don't change it and show you, oh, it's all perfect solution. These are the problems you run into when you're trying to do this stuff. So you could check your Wi-Fi router or access point to see what IP address it gave the device. You could hook a monitor to your Raspberry Pi. This does have HDMI out. I could connect it to the monitor in front of me, look at the console, and have an IP address on it. I happen to know the IP address because we could also SSH into it with the IP address. So it should have pulled, because I've used this device before. 168, 179, and let's see. Aha! It is up and running. So the first time you connect to the device, it's going to ask you, hey, this is a new device. Are you sure you want to connect? You can say yes, no, or view the fingerprint. Well, part of the fingerprint showing to you there. We're going to go ahead and, actually, I'm going to cancel out of there. Let's try our host name again, now that we know the Pi is actually up. So let's try local. So the name translation is working. I just didn't give it long enough to fully boot before I tried it. So we're going to go ahead and say yes. All right, so now it wants a password. And this is going to be the password you set when we were building that configuration for the SD card. And if I typed it right, we should be in. We're in. Yes, we did it. All right. Woohoo. If you're using Pi, I highly, highly suggest, because you're using the default user and default username, you run PASSWD. That'll change your password. It'll prompt you to change the password. If you're using the password you set up, you don't need to do that step. All right, our next step. Let's get this thing up to date. But Kevin, we just set up the card. What do you mean? Well, that's an image. That image could have been built 3 months ago, 6 months ago, a year ago. We need to make sure that we have the most recent versions of all of the operating system in order to continue. So how do we do that? We're going to type out a few commands, and they're all in this step-by-step guide. So don't worry, we're going to walk through them together, and you can get a copy of this guide for free. The link will be down in the description. So we're going to do sudo. That allows us to act as the administrator of the box because we're a non-supervised user. And we're saying, as a supervisor, do this action. APT, which is an application that allows us to install, remove, and update software. And then we're going to tell it what we want to do. We want to update. And this is going to update a list of all the current versions of software. This isn't going to actually upgrade any of the software. Hit enter, and it's going to go out and do its thing. Start downloading all of the files that tell us here's the latest versions of the packages. Perfect. It is telling us 58 packages can be upgraded. Now we could view a list of these packages to see, I don't care what they are. We're just going to upgrade them. So our next command will go ahead and upgrade those packages. And don't worry, I'm not going to make you sit through it. we're going to speed it up in editing. So we're going to do sudo. We're going to run our apt again. But this time we're going to say upgrade. Now, if we just hit enter right here, it's going to prompt us. It's going to give us a list of everything it's going to do and then say, are you sure you want to do this? Yes or no. We're going to avoid that, but we're going to hit dash Y. That's going to tell it we already authorized. Go ahead and upgrade all those packages. All right, it's finished. Now, some of those changes may have involved stuff that is related to the kernel or the core piece that only gets loaded when the system is booted. So we need to make sure we do a reboot of our Raspberry Pi in order to ensure we've got the latest version of all the software that we just installed. So this is pretty easy. We're going to do a command again. We're going to type sudo, and we're going to simply say reboot. Now, if we ran reboot as a normal user, it'd say, you ain't got permission. That's why we need the sudo. So let's go ahead and enter. It's going to restart. Now, we're going to give it a couple minutes before we try that connection because got to let it boot. So I'm simply going to hit the up arrow key to get us our last command that we ran. Let's see if she's responding. Ready? Boom. Doesn't look like yet. Give it just another minute. Why? Because this is real world. I don't want you to have false pretense that everything happens in the matter of seconds. Let's try it again. Oh, prompt for a password. And like that, we're in like Flynn. All right, so now we get to install some other needed software. Now these packages, some of them are related to development tools, what we will need to build Direwolf once we download that and install it. There is some stuff in here for GPS support. You may not be doing GPS. If you're doing receive only, you really don't need it. If this is going to stay in a fixed location, you really don't need it because you can hard code the GPS location. If you're going to be taking this mobile, you'll probably want to put a GPS on there. We are going to install the GPS components in case we ever decide we want to put a USB GPS dongle on this. And lastly, we're going to install some other tools that are useful for working with our sound device. So let's get started. We're going to copy our command instead of typing all of this out. We're going to come over here and we're going to paste it. Now you'll see after I paste it, you just right click on the button. There's no right click and then paste. You just right click and it'll dump what is in the clipboard to the prompt. And it'll highlight it all. We're just going to hit enter. We're going to let this run through, install those pieces of software. The flavor today is unsweetened iced tea. Sorry, no flavor. Just tea. I should say unsweetened black iced tea. There you go. Now you know. Drink the hard stuff over here. Again, this may take a couple of minutes. I'm going to go ahead and speed it up. All right, our next, we're going to do our GPS. Oh, I just saw when I copied and pasted, the way that it pasted out, it did not take our last item as part of the install. So we're going to just make sure that we got that. We're going to do sudo apt install -y lib udev -dev. Always be reading your screen to make sure that, no, it's, what's it doing here? What's it doing there? Oh, there it goes. All right. So yeah, so the way that I copied and pasted it out of the guide, for some reason, because it's on that second line, it saw it as a separate command and not part of our structure of a single string. So if in the guide it word wraps, just make sure that you're keeping an eye on that. So our next line we don't have to worry about. It's all one line. So we're going to go ahead and install the GPS stuff. Again, you could skip that part if you don't ever plan on hooking a GPS dongle to this. To me, the couple extra seconds it takes to add this piece in there, it's worth it. So if you later decide you want to take this Raspberry Pi, throw it in your vehicle, hook a GPS to it, you are good to go. And this takes just a couple of minutes. We'll get all these tools installed. All right, that step's done. Now we move on to installing our sound card utilities. So we're going to copy, we're going to paste, we're going to hit enter. All right, so you'll see this message come up. You can do this. It just helps keep the system clean or not. So in our process, one of the packages is a newer package than the other, and it kind of changed some things. And it's saying we no longer need this lib yuv0 package, and that we can run the command called sudo apt auto remove, and it'll clean all those up. You may have one, you may have two, you may have 20 on your computer. It may be different. So we're just going to go ahead and run that right now. I know it's not in our guide, but that's okay. Auto remove. And that'll just take a quick second to go ahead and remove that package. Oh, I didn't do the -y. See, now it prompted me. Do I want to continue? Yes. That's what our -y does. It doesn't keep prompting us to do the action. I already gave you the instructions. Do it. All right. We're done, right? No. We now have our Raspberry Pi ready to go. Latest software versions, our developers tools, our GPS tools, our sound card tools. So now we can get to the guts of Direwolf. Direwolf is a software that's known as a TNC, or Terminal Node Controller. This is the brains of our operation here. This is what's going to decode those APRS packet signals that we heard earlier on the video, and then handle all of the iGate functions as far as taking that data and sending that information to the internet servers for APRS, as well as, bring packets in from that internet service. All right, let's get started. So we look at our guide. Our instructions say that we need to download and compile. So we want to make sure we are in our user directory. So that's simply cd and then the, I think it's called a tilde I don't know. You guys can correct me in the comments below, because I'm sure somebody out there will tell me if I'm incorrect on what that symbol is. That simply is a Linux shortcut that says go to the current user's home directory. So now we're in there, which I was already in there. Now we need to run a command to get the latest version of Direwolf from their repository. So we're going to go ahead and copy this. We're going to paste it. We're going to hit enter. And that's going ahead and downloading a version of it, storing it on our computer. But by using this repository with the git command, this will allow us to easily go through, and you'll see that in the maintenance section of our document if we later want to update to a newer version of Direwolf. Because it's not an installed package and we're compiling it locally on our computer, this repo will allow us to interact with it and say, okay, I need the latest version. So we go in and run a command, and it pulls down the latest version. Then we recompile it, and we've got the newest version of Direwolf. So we're just going to give this a second to finish up here. Looks like we're about 45% of the way in there. All right, so now that that's done, we're ready for our next step. So first thing we want to do is we want to change into our Direwolf directory, simply a CD, very similar to Windows. Now we want to build, we need to make our build directory and then change directory into that. Now you can see here we're doing two commands at once. By adding these two ampersands in the middle of it, and signs for those of you who don't know what an ampersand is, it will make our directory called build, and then it will change directory into build. So we're going to go ahead and run that. And now we need to configure our build. So we're going to simply run cmake space ... All right, now we're ready to compile. Now this process is going to take a little bit of time. We're going to tell it to use 4 cores of our CPU in order to help make it faster on this compile. But I'm going to speed this up in edit so that you don't have to sit through this entire process. We're going to simply type out make -j and the number 4. All right, our build is done. So we're all done, right, Kevin? No, we gotta do some other steps, including some verification and configuring of Direwolf for our settings. Let's get started. Our next step is to go ahead and make our install files for Direwolf. So this will install it system-wide. Why? Because we want this device to be able to have this as a service, and we'll get to that here shortly. So that when power goes out or it needs to be rebooted, that you don't have to go in and do anything else. It just starts automatically. So let's go ahead and do our install, or make our install files. All right, so that took it and put it all out into a common folder. Now we're going to do our configuration file, which will put this into our users folder. Boom. All right, so let's verify our installation that we did everything right. And we are going to type Direwolf-v. Now, I know -v is not really an option. That'll give us the error report that'll show us all of the possible commands and let us know that it is working. Oh, look at the white screen with the red writing. Don't get alarmed. That's not an error. That's just Direwolf's way of reporting it out. So you can see Direwolf release 1.8.1, November 2025. We got the latest version. As in my guide, it says 1.7 or later. We got 1.8.1. We're later. And as you can see, here's all the commands that you could possibly run with Direwolf. Now, chances are you won't need to manually do any of this because we're going to set it up one time, set it up as a service, and then from there, we'll take care of everything. Before we do that, let's go ahead and check out our audio sound card and make sure it's all working correctly. So I'm going to change directories to my user directory again. So CD, boom. All right. And I'm going to type clear, and that's going to take all the Direwolf stuff and get it off our screen, just like we thought. Clear the screen. That's just to remove the clutter, the color contrasts, and all of that fun stuff, right? All right, so our first step is A play, one word, -L. And this is going to say, use the A play utility and list out. Here's all of our audio devices. So depending on which device you used, now in our case, we used the Digirig. We're going to be looking for a USB audio device. As you can see right now, we are card number 1, device 0. Okay? This output, we don't ever want to use card 0 headphones jack. That's the actual sound card that's built into the Raspberry Pi. That's something we can't interface with. So we don't want to ever use that card. And sometimes you'll see this other card come up and it'll be an HDMI. That's the HDMI port because it has sound capabilities built into it. Now you may find at times card 1 and card 2, our USB device and our HDMI device, will flip-flop. Sometimes the USB will be card 2 and the HDMI will be card 1. So if later on you're running Direwolf and it's not working right, run this command again, this aplay-list, and make sure that your cards didn't get flip-flopped, because we'll need that information here in a few minutes when we configure Direwolf. All right, so card 1, device 0. Now we want to take a look at our audio levels. What can we hear? What's coming in? So we're going to run a utility. Now, if you remember, we installed the ALSA utility library. So we're going to run what's called ALSA mixer. And what do you think that does? Oh, shows us our audio. Now, this is currently set to the headphones. We need to change this to our USB device. So we're going to hit F6, and that'll allow us to choose our devices. We want device number 1. And now you can see we have our speaker, our mic, our auto gain control. We are currently in the playback view. So as you can see, there's up in the left-hand corner of this window, it's F3 playback, F4 is to go to capture card, F5 will show all of them. So on the playback screen, we are on speakers, and we're going to go ahead and use the arrow keys to increase this to about a 70 to 80% level. So we're going to jump this right up, and we're going to go it's close to 70. Wait, 73. What do you know? That works for me. All right, so now we're going to use our right arrow key to go to mic. And since this is going to be receive only, we're not going to really worry about it. Plus, it's muted. You see the MM? That tells us it's muted in there. Our auto gain control, we want to disable that. We don't want that on there. So we're going to come over here and we're going to type MM. Or just 1M, sorry. That'll automatically turn off that auto gain control. Now let's go ahead and take a look at our capture, which would be our mic side of if we were going to transmit out. So I'm going to hit F4 to switch to our capture. And right now that's at a 41. We're going to go ahead and increase that just a little bit. We're going to go up to 60. We're going to leave it at that. Now to get out of here, this auto saves as soon as you make those changes. To get out of here, we're just going to hit the escape key, and that'll exit right back out of that mixer. We could do a test recording if you wanted to test this out. You could... Woo! I need a drink. My tongue is getting dry. Now you have an option inside our guide to be able to do a test recording so you can hear the audio levels. I am going to skip that point in this video because it's unnecessary. So you could run this command, the A record. Just make sure you update this numbers right here to be the exact location that your card was. So in my case, it was card 1, device 0. So this would be 1, 0. Right? And that would save to a file called test.wave. And then you could play it back on this device if you had speakers hooked up to it. You could do a play and then the test.wave file. Or you could log in with like something like FileZilla through SSH, download it to your computer and play it. And that's why we're not going to go over it here in the video. Too much to overcomplicate it for you. More or less, we've set the settings. We can come back and change the settings if it's not working right. You know, you can go through and troubleshoot it. If it's too quiet, increase the volume inside the mixer. It's too loud, decrease the volume, either on the radio, in the mixer, no sound at all. Then, you know, make sure your numbers are correct. Make sure it's using the correct card and device. Let's jump to part number 5, configuring Direwolf. Now, we're going to need to get our APRS IS password. So to do that, we're going to come over to this link. We're going to go over to our browser. We're going to type in and paste and go. Now, there are multiple tools out there that will do this for you. They'll generate your call sign into an APRS password. So I'm going to use my call sign. You use yours, otherwise this won't work, right? We're going to say generate passcode. And it's no secret. Like, this isn't something that I have to hide or conceal. Literally, any of these tools, I could type in anybody's call sign and it'll show me that passcode. And no matter what device I go to or what tool I go to and run this, I will always get that same passcode back out. This is just a way that it can confirm that, yes, you are who you say you are. So 19634. So we're going to need that here in a second. Let me switch back over to our shell. So we are now going to change directory back into our user directory, which we already are. We're going to type nano, which is an editor. Direwolf. Oh, wolf, not wolf. .config. C-O-N-F. Conf. Give me the conf file. All right. Now this is where you're going to get scared. Like, oh my God, what is all this that I'm doing? We got you. We have a sample configuration right here. Do not, and I repeat, do not just copy all of this and paste it in there. We are going to go line by line. There's things that are specific to your computer, your devices, your call sign that we need to set up accurately in order for this to work. So we are literally just going to go through this file line by line. So first thing we're looking for is our audio device. So we are right there. As you can see, it's commented out. So we're going to remove the hashtag and we want device 1.0. Now again, make that to be what your device is. Card number, comma, device number. So if you are a 2 and device 0, it's going to be 2, 0. If you're card 1 like me, it's going to be 1, 0. All right. Now we also want to tell it how many channels we're going to have. And we're going to say 1. All right. Now we're going to come down here a little bit further. We're going to have some channel properties. Channel 0. As you can see in my example, I merged channel, my call, and the modem all to single lines without all of this other text in here telling you what they are and what they do. This is why we're not copying completely out of there and pasting into here, because you will lose all these instruction files in case you have to come back in here and edit this again. So my call is going to be my call sign, K2DFQ, dash, and 10. Now, where do I get that 10? Well, let's take a look. You can put whatever number you want. However, there are some standards that people try to use. Not symbols. Identifiers. So SSID recommendations from APRS.org. 0 is your primary station, usually fixed, message capable. 1, 2, 3, and 4 are generic additional stations. Could be digital, could be mobile, weather, etc. Yes, weather devices also use APRS. You'll see them shortly on the map when we pull them up. 5 are other networks like D-Star, iPhone, Android, BlackBerry, etc. 6, special activities, satellites, ops, camping, 6 meters, whatever. It's your idea of what a special activity is. Dash 7s are typically an HT. 8 could be a boat or a sailboat, an RV, or a second main mobile. 9 is your primary mobile. So I use a 7. That's my UV Pro. My 9 is my Asus in my vehicle. 10, which is what we're going to use here, is for Internet, iGates, Echolink, WinLink, AVRS, APRN, etc. If you want to set up an aircraft, a spacecraft, or balloons, you could use a Dash 11. A Dash 12, DTMF, RFID devices, other one-way trackers. Dash 13 are typically weather stations. 14 are truckers or general full-time drivers. 15 is general additional station, digi, mobile, weather. And so on and so forth. You could use 16, 17, 18, 20, 52, 96, 25, whatever. Right? So, and there's more information in here. It tells you recommendations. Now, do you have to use those? No. They're just recommended. And much like the ham hobby, you will get some dinosaurs. You have to use this identifier. No, you don't. Recommendation. Says it right here. APRS's own documentation. SSID recommendations. Use what you want to use. And they give you a little bit more in here about this. You're more than welcome to read that anytime you want. So let's get back over to our configuration. So we're going to do a Dash 10. Now we need to set our modem. And again, there's instructions in here. We are going to set ours at 1200. Why? Because that is the most common for VHF, UHF. Okay, now we want to scroll down in our configuration and our push to talk. But Kevin, we're doing receive only. That's okay. We're still going to configure it in case you decide later you want to make this a two-way function. Now, there's some additional tests you're going to want to do if you do want to do this as a digipeater. You're going to want to verify that, this is actually working with transmitting to your radio and all that fun stuff, or being able to activate the push to talk button. Some radios you might have to use Vox. So, all right, so now we need to configure our APRS IS server connection. And that's going to end up being down below our beacon. We're going to come back to the beacon in a minute, don't worry. There's all of our digipeater if we decide we do want to turn it into a transmit. Here's our internet gateway. So I'm in North America, so I'm just going to uncheck this because I'm going to use the North America APRS2.net. And what that'll do is it will try multiple servers that are in North America and just keep round robin them until it gets one that has an open connection. Don't be alarmed when you're doing this if you don't get failed connections. You'll probably see it when we do our test here in a minute. Because some of them only have, so many slots available, and if they're all taken up, it'll have to go to the next server to try. That's okay. We also need to add in here our login, which is right here. And this is going to be me, not them. So this is KE2DFQ-10. And this is where we needed that passcode. Remember the passcode we just generated a few minutes ago? It is 19634. And this is going to be 19634. If you get this wrong, it will not let you log in. You'll have to come back into the configuration and change it. Now we need to configure our, am I jumping ahead? Yep, in my documentation we did beacon next. But since we're here at this spot, we're going to go ahead and fix what channels we're going to use and what paths. So, and then we'll do the filter in a minute. So we want to go back up here to our beacon. Now, I will warn you that the examples in this document for the beacon don't work. When I've tested this before, I've had issues with the lat and long, putting it in as this decimal format, or digit format, and had issues with APRS IS servers not reading it, not accepting it. You got to go to the decimal format. So where can you get your lat and long and get it in the decimal format? Oh, there's a site called GPS Coordinates. And I think it is, oh, it's .org. Glad I went and checked. I'm almost going to tell you .com. .org. And so what we need is this degrees, minutes, and seconds. So if you put in your address here, which I'm going to allow it to use our location. Of course, there's going to be tons of ads on the site. That is not where I'm located. It's around the corner, but not. GPS matters. It can make a huge difference. So once I get GPS coordinates. So as you can see, it gives me my 43.097 and negative 76. And if I plug those in, that's where I was having problems. So what I needed was it in this degrees, minutes, and seconds format. So in our example document, you'll see that our beacon, I have it in 43 0.5 by 8.9, which is a little bit off of what they have there, but 43.5, 8.9 north, and in there he's saying 50.9. Yeah. And then the 76.6 by 81 west, and I'm at a 50.72. So it's probably just going to be where it places me in this building. I'm actually more over here on the side. I grabbed mine from a GPS, which is where I got it in my documentation. But, you know, close enough. You put it in there. If you need to tweak it and where it shows up on APRS Fi, you can go back in and fine-tune those numbers. So I'm going to copy this beacon statement. I'm going to come back to my document. And we're just going to add a new line, a couple new lines here. And then I'm going to paste that. And as you can see, because in our document it's on multiple lines, it tries to put it on multiple lines. We need this all to be one line. So I'm going to go to the end of this line, and I'm going to delete, but hit it space. We go to the end of the line again, space, and delete, so it brings it all up into one line. Now, you want to adjust this for your settings. We're going to go through these settings right now so you understand what each one of these are. Send to IG. That says send my position beaconing to the Internet Gateway. Why? Because we're receive only. We don't have anybody else reporting our beacons if we were doing a transmit beacon over RF. So we want to show up on the map on APRS Fi. So by saying send to IG, it'll send our position to the Internet Gateway. Delay of 1. You can set this as 0. You can set it as, you know, whatever. This is the amount of minutes it'll delay before it sends its first packet to say, this is my position. Delay of 1 just allows it to go through its setup, try to find that first internet service that it's going to connect to, the server that it's going to connect to. Sometimes it still doesn't happen. You'll get your beacon goes out, and then it'll finally make a connection because it's failing on several of them before it gets out. So at that point, you're going to wait till the every cycle number in order to get the next time it'll send a beacon. If you want to test this out at first, you can set this as 0 and then every 5 minutes. Right now, I'm set at 1 every 30 minutes update. We are going to go ahead and change this to 5, and I'm going to say 0 because I want to see in this video instant results so you guys can see it, right? Our symbol is going to be an iGate, and our overlay is going to be an R because we're receive only. If you decide to set up a digipeater, you can change from iGate to Digi, which will give you the symbol on the map for a digipeater. And the overlay in the center, you can choose the letters you want. I think a lot of people use S, an uppercase S. If I wanted to leave it iGate but have transmit abilities, I could change that R to a T, then the symbol in the center, and we'll show. Matter of fact, I'm talking about it. If you've ever seen APRS Fi, you're probably going, Kevin, what the heck are you talking about? Let's go APRS Fi. And you'll see it's going to pull up a map around me of all the symbols. So see how these symbols are? So that's a red diamond with an L in the middle. This is a black diamond with an R. That's what ours will show up, set as an iGate, receive only. So we should show up on the map right somewhere right here below the airport. These other symbols, as you see the WX, those are weather devices. So things you put outside your house that, tell you, hey, this is the type of weather. The green star, that's the Digi. And as you can see, this one has an S. This one up here has looks like a D. So, all kinds of different meanings. Here's a black diamond with a D. So, while yes, there is a standard that you can follow, you don't have to follow. Nothing says you have to use this symbol and this marker. There are a ton of different options. As you can see, here's one's a tower. When my vehicle's on there, it's a truck, little picture of a truck that runs around. My HT is a person running, right? So, yeah, you can have all kinds of different symbols on there. There's a whole list of them. And if you go out here and Google, just like what we did for the identifiers, if we say APRS symbol, it's going to take us and show us these big charts. And there's a lot of different people that have them all on there. We're going to go to the one officially from APRS. And these are all the different characters we can have on there, the symbols we can have on there, the alternative symbols, and how do you get them with using the overlays, the primary symbol. You can go through all that and figure out what you want to use, right? So, all right. So let's get back into our configuration. And I'm actually going to put us back on the map and then bring our configuration up so we're not got all that other stuff bothering us. All right, so then I have my latitude, my longitude, the power I'm putting out, which is 5 watts, the height of my antenna, which really isn't because I'm on the HT, and the amount of gain from my antenna. And then you have this area for a comment, and my comment is Ham Radio Playground iGate, because that'll show on the map. So if I come in here, and sorry, that's right, the camera's right in my way. So I'm going to say, let's search. Why is that box still there? Search K2DFQ, right? And this will show all of my devices. And as you can see, I have Ham Radio Playground, which is my vehicle. I told you I had a picture of a truck. Dash 10, my Ham Radio Playground iGate. Why? Because the SD card before we did this together was already an iGate. So I wiped it out and just redid it so that you guys could see a step-by-step how to do this. My Dash 2 is a DigiPi, which is no longer set up. As you can see, it hasn't been active in 260 days, 1 hour and 7 minutes. This is the last time it was heard. My truck was almost 5 hours ago. Is it really that late in the day? Yeah, it is. Wow. It is almost 1 o'clock. It's 12:44 right now as I'm filming this. So, yeah, it means I've been here at my office already 5 hours. Great. And then my HT, because it's sitting in the window back there, shows ham radio playground and the voltage on it. So, and that was last heard an hour and 39 minutes ago. Why? Because about an hour and 39 minutes ago, we wiped out this iGate from running, so it's not reporting into anything. Because I'm inside a building which is pretty much like a Faraday cage, with all the metal that's up in the ceiling and the metal roof, not a lot gets out. So every now and then I can hit over here on N2RD, which is quite a distance from me. I'm right here, which you would think some of these other ones would pick it up. My little HT. N2RD is elevated. He's up a little bit higher. Every now and then he'll pick me up and report me on my HT. So, but that's where that comment comes into play. And you'll find that people have all kinds of different things on their comments. So if we click one, you know, powered by WPSD. So, you know, this one is power. You can put what the antenna height, the gain. It's omnidirectional. Its range is about 8.9 miles. All that fun stuff. All right, enough of that. Let's get back into our configuration. What else do we got? Our filter. Okay, this is what kind of packets do you want to receive back from the Internet Gateway. We're going to say within 500 kilometers, so we're going to scroll back down. Use our arrow keys again. So I used the home key to get me back to the left side of the screen. And right underneath here, excuse me. Woo! Apologize for that. So right here, right underneath where I put my gateway, I'm going to add another line. And we are going to type out IG filter M/500. You can set this to what you would like. Even at 500, you're going to get a ton of packets coming in, and that is just simply what's coming in from the Internet Gateway to your device. If you're not retransmitting those out, so you're not a digipeater, not going to make much of a difference. It's just going to constantly have stuff flowing into your console. You can set it to 0, you can set it to 10, you can set it to 500, 1,000. You can leave it missing. As you see, because we have this filter in here, it'll warn us every time we start Direwolf that this is an advanced configuration and the average device doesn't use it. So, see, just caught an issue. Because we're on Linux, because I had highlighted it with the mouse and then typed, I didn't delete it. So good thing we're double checking this, right? So there's a couple other settings left to do. And these are some additional settings. They don't have to be enabled, but if you want to be able to connect to your gateway, you can set up port 8000, which is what we're going to set this up for AGW. That allows APRS software to connect to it. So maybe you got an APRS client running on your Windows machine, Mac OS, Linux machine, whatever you got, right? Maybe you want that to be able to connect to your gateway. You can connect it to the port 8000. Maybe you want to set up a KISS port to be able to also use other software that connects to it. So we're going to set that up in 8001. So we're going to come all the way down here to the bottom, and we're going to simply type these lines. I'm going to copy and paste them because I want the comments to go with them. And the last one I'm going to leave disabled, which is the GPS support. If you're doing GPS, go ahead and so we're going to add some spaces in here. No, I want space. Get with the program. So I'm going to turn on my port 8000, and I'm going to turn on my KISS port at 8001. And again, if you're going to do GPS, remove this little hash symbol for GPSD. That tells it you have GPS support on the device. If later on you decide to turn this into a mobile device, remember, come back in here and make this change in the configuration, restart Direwolf, and you'll be good to go. So we have everything. We got the key values that we needed to change our A device to make sure it's our card. We have our call sign and password, our lats and longs, and our comment. Remember, customized for yours, because mine says Ham Radio Playground iGate. Yours does not have to. You can if you want. I would love it, but do not have to. All right, and then you can change your symbols, your overlays, all of that fun stuff, right? So now we're down to save and exit. So it's Control X, which brought up our menu. So I'm going to hit Control X. Save modified buffer. Yes, because I don't want to lose those changes or we're going to have a basic config again. Where to write it? The same file we were in, which is direwolf.conf. So we're just going to hit the Enter key to say, yes, that's where we want to save it. Now our configuration's saved. If we open our file back up, you will see, and you don't have to open it back up to see, there's our changes. Card 1, we added the channel. There's my call sign. Boom. We got everything in there. Control X to get out of it again. Now comes time to test Direwolf. Let me grab a quick drink. All right. So we are going to run our command, and this is before we turn it into a service on the device. This is us going to run it once, kind of make sure everything's working, everything's connecting. So we are going to type out direwolf -C to tell it we want to use our config file, our little user directory / direwolf. Oh, conf. Wow, my fingers did not want to type today. All right, Direwolf started up. Let's see. Warning. I told you that IG filter is rarely needed expert level feature. If you don't have a special situation and good understanding of how it works, you probably shouldn't be messing with it. The default behavior is appropriate for most situations. Please read successful APRS iGate operation.pdf, which is available from Direwolf. So this is telling us that it's using card 10, channel 0. We're set at 1200 baud. It's going to sample at, 44.1. And you can see it's ready to accept AGW clients, ready to accept KISS TCP clients. And then you see the pink line towards the bottom that says IG, my call sign -10, and then a whole little string. Well, that's that packet it's sending to the gateway. But we haven't connected to the gateway yet. It's just kind of sitting here right now trying various locations. So once it connects successfully to the gateway, it'll spit out some more text for us. So what should you see? Exactly what we're seeing, except for we haven't gotten to this part yet where it says it connected to the iGate server. So, and then we should start seeing it decoding packets. So we're just waiting for it to kind of go through and connect to the gateway. And my packet does not look correct. I'm just looking in there in the string at what it says. There we go. So there's all the failed connections. Remember I said it was going to go through trying? So there we go. We successfully connected to this one. So we went through several servers, and there's the flood of traffic coming in from the gateway server. So we went through, and it attempted here to this first connection. It failed. So that big long string is an IP6 version. That's an IP4 version. It tried this one. Then it tried then another IP6, IP4, 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 IP6. They all failed. And it's nothing to do with your device or your internet connection. Could simply be that they're either offline or they are full at the moment and they're passing you to another server. That's why we use this northamerica.aprs2.net, because it will find the next available server in the queue that we can connect to, which it did. It finally connected to this one, 44.184.136.10, and it tells us we can check the status here. So if we hover over that, we get the line, we hit a control key, it will now open in our browser, and it shows we are connected to the Alberta in Canada server. So in here you can see everybody that's kind of on it, and as you can see it said feed was full. So that's at times when it shuts off from being able to send things to people. But here I am right there. There's my packet. It says was heard 1 minute. Last heard 12 seconds ago. It's been verified, which means our password was good. I'm running Direwolf 1.8, and here's my packets, my bytes, and there's my filter, M500. As you can see, this person's using M24. These other people have some other filters on. So, and here you can see everybody else that's connected to this same gateway that's iGates or digipeaters out there. And you'll find some who load things up with the default configuration and don't change things, because you'll find, let's see if I can find any in here. You'll have call signs as no call. You'll have, all of the default stuff that we went through and changed in our configuration, and they won't have that information in their setup. So let's scroll down in our logs here a little bit more. And as you can see, the packets are coming in. So we can see IG, this is us communicating with the Internet Gateway. IG, and then like an arrow or a caret, TX, this is the stuff we're getting from the Internet Gateway. So these are packets that we're not hearing over the RF, we're hearing them from the Internet Gateway that are within 500 kilometers of us. What we'll be looking for, and I don't know if it's happened yet or not. I'm trying to find the one for our local device, and if need be, I can shut off the gateway. So here's one that had some issues, but that's okay. It's just giving you all of the status of it. It's not something that you got to really respond to. And you don't have to sit here and watch this log. This thing will just work in the background doing its thing, right? So, here's somebody that had their SSID out of range. So using a 99 is not acceptable. They wants a 0 to a 15. So even though I said you could use 25, you could use these others. Yes, you can, but it's going to give this warning saying it's out of range. And I'm not seeing my other HT yet, but like I said, this log will fill up, and I think that's set to every 20 minutes, 30 minutes. I don't remember what that HT is set to transmit out. But our gateway's up, it's running. Come on. What we'll do is we'll go refresh our map and see if our data's on there. And we're set to every 5 minutes send out our beacon. I said when I looked at it, it didn't look right to me the way it showed. All right, so there we go. There's our beacon that we sent out. And that string does not look right to me. So we're going to double check everything here in a minute. Make sure it's showing up on the map. If you don't show up on the map, then it's usually something to do with your positioning you're sending. Just trying to get to the bottom of the list to see if our HT is reported in here or not. You know what? The map's going to show us. So let's go over here to the map. We're going to close this out. And I'm going to refresh the page. And look, there is our iGate reporting. That's us. We weren't on the map a minute ago. You know, it's saying 4 watts, even though we told it 5. 10-foot gain, 2 dB, omnidirectional, range is about 3.4 miles. So that range is telling us where we're getting heard, or what we're picking up, what we're receiving in. So we must have gotten somebody that we've picked up. So I'm going to click Info. And this is going to take us out and show us a little bit more. So here we are on the map. It did pick up the right location. It's telling me that it was last heard 3 minutes and 55 seconds ago. We were running Direwolf. And we were heard through Alberta, which is the service we're connected to. T2 Alberta. Right? And we have 3 positions that have been stored. 1 radio on the path that we've heard. And packets, we've heard 15 on our radio path. So, and what have we heard? We have heard my HT. Remember I told you I had a little dude? So, all right, and it was heard yesterday. So it's pulling up from what was in the history of it. So it hasn't heard it since we fired this up. So if we gave it a little bit more time, then, you know, obviously we'll hear that packet from my HT. And while we're waiting, we will start the rest of the steps in our application, because we've seen that this is working. It's connected. It's making contacts. It's reporting to the map. All of that fun stuff. And we will put a script on here that we can see what we've connected to, or what's connected to us over RF. It'll filter out all of this nonsense that's coming in and from the gateway. So let's switch back over to our documentation here. So we opened up, we show on the map. So again, it's after a few minutes. Make sure our beacon went out. If we need to adjust our audio levels, which might be why we're not reporting any of the tones from our radio. Let me power up another radio so we can hear when that thing transmits. Or maybe I'll just go grab that out of the window and bring it over here. Give me 1 second. All right, so I brought back over the other Mini, have it turned on so we can hear, and I brought back the UV Pro that is the second APRS device that we're looking to see it be received. Now, I did key it up in here, which broke our session. Obviously, the Raspberry Pi didn't like being right next to the radio when I keyed it up. I was trying to force a packet to go through, and it just bloop. So, it caused Direwolf to crash. So, we are going to clear our screen. And we're going to continue on to our next steps, because we may have to adjust the volume either on the radio or go back into the mixer and adjust the volumes, because it might not be hearing the tones. So what I'm going to do is I'm actually going to, on the radio, I'm going to turn the volume up a little bit. So I'm almost at the max. And then we are going to, let's see, that's working for us. We're connecting. These are a bunch of troubleshooting steps, making sure you get out to the internet, your filter. So before we get into the automatic startup, we're going to run this again. We're going to close out the previous server that we connected to, because we're going to probably connect to a different server this time. So what'll happen is if my volume is too loud, it's going to give me an error. But I found that sometimes it reports an error saying the volume's too loud, and it needs to be that loud in order for it to hear it. Because when I lower it down to the levels where it wants to be, so that Direwolf is happy with its statement, it doesn't pick up the beacons. So we got Mini number 2, so Thunder is set to the APRS frequency so we can hear the packets when they come through. And then I've got the UV Pro over here that is going to be sending a packet. So I'm going to put that guy over here away from the Raspberry Pi. While that's trying to find a station to connect to, or server to connect to, I'm going to refresh APRS Phi. Let's go map view. No, I don't want any call sign filtered in there. All right, so let's go back to our SSH. Just waiting for it to find a server to connect to. All right, the group of failed. Real world. No sense in editing this out and like telling you that, oh, it just magically works. Right? I'd rather have you guys see the truth than come back and go, I followed every step in there and things didn't work. And you feeling like it was something you did. Playing radio. Hurry up and wait. Need to add the Jeopardy sound effect to my mixer so that we could play that while we're waiting. Oh, the joys, the joys. Well, it looks like it's going for another round. There we go. We've successfully connected. And I am going to open that guy. Where'd we connect this time? Oh, I can't see because it's in the wrong screen. We connected to Vancouver. Well, that's quite the distance. All right, so let's get back over here. Since we're verified. There's our beacon. So we had waited 5 minutes for all of that connection between our first attempts and when we finally connected. Where is... Although I haven't heard it beep. It may be the building playing tricks on me. That's why I keep it over the window to send. Let me see if I can force. A packet. I heard the tones. Let me get to the bottom of my list. Ooh, there's a bunch of garbage that came in. The problem is this is a sea of call signs that I'm quickly scanning, looking for my call sign, and not seeing it. So there we go. So remember I said it's going to report about the audio level being too high? And this garbage is because I manually keyed up the radio. It's not what it was being reported. So we are receiving now. I know it's getting the data that's needed. All right, so we are good to send this or continue on with the next steps, where we will be. Well, it looks like that just keyed up again. So do I have a new packet? I'm going to look for the error messages instead of my call sign. Okay, we're at the bottom of the list. And I'm going to kill the server running. So that's a Control-C. All right, that took us back out. So now I'm going to go clear, because I want my screen cleared. We're going to close out this status. We're going to return to our document. And now we're going to set it up so that it'll automatically start, because we know it's working. So we are going to type out sudo nano, and then we're going to edit a file that is a system file. So etc/system/direwolf.service. Okay, so now in this file, it's a brand new file. There should be nothing in it. We're going to copy and paste. So we got that part. And there's one additional line that we need to add. And it does not like the spacing that's in the PDF. So in our file, we will come back in here. Not that it's needed, it's more for visual appearances than anything else. Then we're going to add our additional line that was on the next page. Couple key changes in here, especially if you changed the username when you first set this up. If you're not running as the Pi user, we need to update this. So our user, you're going to put your username here. So mine is Kevin. Your working directory, because you're not going to be in home Pi, you're going to be in home Kevin. And then we also need to come down here and say where our configuration file is, because it's not in home Pi, it's in home Kevin. So that is critical. Otherwise, your service will fail, saying it doesn't have access to the config file or doesn't have the right user permissions, all of that fun stuff. All right, so this is good. We're going to hit our Control-X. We're going to say yes to saving it and yes to our file name. That part's done. So our next step is to enable and then start the service. So we're going to reload the system config so that it sees our new file. We're going to paste that. And then we're going to enable Direwolf. We're going to say, yes, use it as a service. All right, now it created our symbolic link to where it likes to put service files. And now we're going to give it the command to go ahead and start Direwolf as a service. Come on. That's it. It's running, right? How do we know? Well, we can run this next command. So it's basically our last command, but instead of start, we're going to come in here and we're going to say status. Right? We're going to hit enter. Okay, so it's actively running. That's one of the key things we want to look at right here. It doesn't say failed. Doesn't say over here that it failed. And you can see the last few lines of the logs. So it's up, it's running, and looks like it's already connected to the gateway and starting to pull stuff in. Perfect. So we're going to hit Q to quit. And yeah, you know, it's what we should be looking at. So now how do we look at the logs? Well, we can run this command to look at them in real time. We can run this command to look at the last 50. Or we can look at this since the last boot. So I'm going to say here, we're going to look at it in real time. We're going to let this run for a few minutes and we'll watch all the traffic that's coming in. So while we were doing all those other steps after we started that service, it already went out, found to the gateway, which was a lot quicker this time, and is running and pulling in traffic. Problem is, I don't see what gateway we're connected to, and I don't care because we've already verified that piece was working. If we weren't getting this traffic in, I'd be a little more concerned with that. So, all right, good stuff, good stuff, good stuff. Let's refresh our map here. Still has not picked up my HT. I'm going to go put it back in the window. I will be right back. One thing I found with that UV Pro from BTEC, if it doesn't have a clear GPS signal, it sometimes will not transmit APRS packets. It will not send a packet because it doesn't have a location. So that's why I threw it back in the window because, as I said a few minutes ago, this building kind of like acts like a Faraday cage, and a lot of times signal doesn't get out. There are times my cell phone acts really funny inside the building, and it's just the radio waves ain't coming in. So we'll let that sit out there for a few minutes while we continue with our step-by-step instructions. Pretty much we have the system up and running. We could test the automatic startup by doing another reboot at this point. I am not, in order to save time. I'm probably 2 hours into recording this, but when the video actually comes out, it'll probably be a little bit shorter because we are going to speed up a few of the portions that took a little bit more time. All right, so what's the next steps? Well, it's the ability to look at different things. So our monitoring and our maintenance. So we just did the watching the packets decode. So let's switch back over to our session here. So you can see the packets are decoding right there. We could run commands like htop or top to be able to see our CPU and memory usage. So let's go ahead and break our log from showing on the screen. That does not stop Direwolf. That was the point of making it a service. We now can interact with the machine, and that service is still running in the background. So htop. It's a great way to see what's running, our memory, our CPU usage. You can kill things in here. You can run things in here. And you will probably see, if we look somewhere, yeah, there's Direwolf running right there. So I'm going to hit Control-C to exit out of there. Now I'm going to show you the difference of top. That one was very graphical friendly, had gauges. You could use shortcut keys versus its earlier version that is just in here with numbers and text. So, regular maintenance. As I said, we put this in using the Git repo from Direwolf. If you need to do the update, you change back into your Direwolf directory. You do a git pull. You change into the build directory. You tell it to make it. Then you reinstall by doing the sudo make install. And then you want to make sure you restart your service at that point so that it uses the new version. Watch the configuration file. Look at the notes from Direwolf, because if there's additional things that new version needs in its config, you'll want to update your configuration as well. Updating your Pi OS. Those are the same commands we ran at the beginning. Sudo apt update, sudo apt upgrade -y, and then make sure you reboot. Want to check the SD card's health? You're simply going to type in df-h. Ooh, not GH. That's going to show you all your drives in the system. So if you have additional drives, a USB thumb drive or something else connected into this, you'll also see that in there. So, as you can see, it breaks it up into multiple portions. It doesn't use it as a whole single mount point. All right, monitoring the logs for errors. You can tell it to say, show me everything for the last hour. And you can specify whatever since, 3 days ago, 2 days ago, yesterday, today, 5 minutes ago. You want to back up your configuration, you can make a copy of it and back it up. If you want to do it from your computer, you can run this SCP, your username. Make sure if you're not using Pi, you change that to your username. And then, with a file you want to back up and where you want to put it. What do you want to call it on your machine? SCP, secure copy. Uses SSH, but be able to do a file transfer. All right, so the additional enhancements, turning on those web-based monitoring tools. We enabled those two, and then you'd have to restart. We already have those enabled in our config. Again, I told you those are optionals. Let's build this statistic script. Statistic stat. Nice one, Kevin. You're building the statistics and the stat all in one. All right, so we are going to use Nano. We're going to edit this file. It does not exist, so don't be surprised when it shows up blank. And we are literally going to copy and paste this information. Boom. What does this do? Well, it says we're going to use Bash as our language for scripting. We are going to echo out to the screen APRS iGateway statistics, echo a bunch of little equal signs, so it kind of gives it a border. We're going to do a blank line. We're going to say service stats, and then it's going to run this command to get the service data and report it back. Then it's going to give us a blank line, and then it's going to say recent activity, last 20 packets. This will show only what RF has received, which a packet just came in. This would have been the time to have the logs up, right? But no worries. We're building this script. I'm going to pull it back up here in a second. So it's going to say, give me, the last number of lines, cut it off after 20. You can increase that if you want. And then it's going to show system uptime. So we're going to hit Control X. Yes. Boom. So we are going to hit the up arrow real quick and take a look at our logs. Maybe. Do I not have it in? Nope. Where did my command go? I didn't save it. Oh, well. We're going to finish with our script. So now we need to turn that script into an executable. So our change mod, add the executable. So change mod plus X, which adds executable to our file. Boom, we run that. So now we can run our script. ./APRS, and I'm going to hit the tab key so it auto completes it for me, and we're going to run it. And it tells us line 10 was not found. What is wrong with... Oh, guess what? Our line break got us again. So we're going to come in here. This needs to be there. It's the only problem with copying from a PDF into here. It doesn't like line breaks. So let's run our script again. There we go. So now we don't see it because it's not in the last 20 packets. So I want to edit this. And I am going to modify mine to say the last 200. Exit. Boom. Yes. Now let's run our script again. Not in there. We heard it. I heard it transmit through. Why did it not come through? And I know if I pull open the log right now, there's going to be so many coming in from the iGate. It's going to take us forever to find it. Let's try this. Let's run our command here. And we're going to say, boom. And we're going to say, and I'm going to pipe this, and we're going to say grep. Nope, I'm going to put my call sign in there. K2DFQ. We're going to say, pull me for the logs for the last hour, and then filtered out to only show me where my call sign appears. All right. So we have our position beacon, our log response, our position beacon. Oh, look at that. KE2, DFQ5. The audio level was too high. But we received the packet, and here it is. We got this packet, its location. It says ham radio playground 7.9V, and then we got our packet again. So 25, yeah, that was what we heard a couple minutes ago chime in. All right, so now let's refresh our map. We should see our little dude. Oh, he's already there. He's on top of me. See how both of them are on there? So now if I zoom in, whoop, too far. There he is. Now what's funny is one has our hard-coded location and the other is in the window. So if we look, one shows on one side of the building, the other showing over here on the building. Neither one of them are 100% accurate. This guy is closer, but I am more like right there. So he's off just a little bit. It's the angle that the GPS is pulling in because it's sitting in the windowsill. So we're working. So now if I come over here and I look at this guy, and we can say, how was he heard? He was heard by -10, which is our little iGate. Yeah, it's working. We're going to come in here and go to info. And we can see it was last heard 4 minutes ago. And it was heard by 10 with a good path. So, stations that have heard this radio directly, none of them today, right? Oh, right here. Last heard was today. Today. So both these guys have heard me. Oh, that's us. W2CM10, that is one of the local radio clubs. That's their APRS iGate. Or I guess digipeater, because it's got the green star, right? It's working. That's it. You've done it. If you followed these steps, you now have a working iGate. I would love to hear in the comments how your process went. Have you been successful? Are you seeing packets flow in? Is your iGate getting radio traffic? Did you need to build a bigger antenna or attach a bigger antenna to your radio? Did you use something other than a UV-5R Mini? I want to hear about your experience. Share them below. Let's get a conversation going and talking about what worked, what didn't work for you. Why? Because it's playing radio. Nothing says 100% every single time it's going to work. All right, let's look back at our documentation. What other things do we have in here? You can look at some temperature monitoring. You can look at the CPU monitoring, adding GPS support, as we talked about before. You can go in and configure devices. Then you'll have to enable that GPSD inside the config. And then obviously restart both services. And the big one, turning this into a digipeater. It's the matter of stopping the service, manually run the config so you can test the PTT. If it successfully works, then go ahead and modify the configuration to turn on that digipeat. Initially start with wide 1.1, and then if that works and is successful, you can add the others in where you're adding, wide 3.7 through 1 through 7, and then obviously wide 1 and 2 and 1 and 2. Those are the different patterns that'll match the type of packets. So update your beacon to make sure that you show the overlays as Digi and then the S, so that you're not just a receive only iGate. And then obviously your comment, if you had it in there instead of iGate, you can put a digipeater. The S is for small or secondary. If you are large, because you cover a wide area, you can use an L. So if you want a beacon over RF, then obviously you'll remove that send to IG from the beacon line. Here's some other settings for PTT. So obviously we set up for Digirig, which is CM108. If you get a programming cable that has the CM chipset, it'd be also CM108. If you're using the signal link, you'll want to use PTT rig 0 and then the device, or you can trigger it off of the GPIO pins on the Raspberry Pi itself. You're going to use pin 23. So, here's an example of the full configuration for the digipeater. So, and then obviously verify that everything's working after you do that, because you'll restart your services. Make sure it's showing up on APRS Fi. And then, some best practices, when not to run a digipeater, what the duty cycles, to take into consideration for the radio you're using. Troubleshooting guide. If you run into problems, there are some common issues that are down here in the bottom of the troubleshooting guide. What the issue is, an explanation of why, and then some options on how to try and fix it. Not appearing on APRS Fi. It can take 5 to 10 minutes for your station to appear. And if you don't have your configuration right, it will never appear. So, simple cost breakdown. It's going to vary from person to person. Raspberry Pi, $35-40. I'm using something existing, an SD card, $1 to hundreds of dollars. How much do you want to spend? I had one lying around from another project. Programming cable. I already had one that I used in my chirp video. Unfortunately, that did not have the audio chipset we needed, so we had to go with the Digirig. If you had to buy a Digirig, obviously you're going to spend some money on that, like 60, 70 bucks. I have several of them laying around here for various different projects, and already had that. You could do a USB sound card. Like I said, you can get these like 10 bucks. I think we threw 8 in here into the guide. Check Amazon, find them. Check around Hamfests. Look at Facebook Marketplace. Look at computer closeouts, eBay. They're not commonly used in the computer world anymore, other than radio stuff. Power supply, most likely you already got one, because you'll be using a brick that you charge your cell phone with, and then just the appropriate cable. Case, either 3D print one, find a buddy with a 3D printer, or buy one on Amazon. They're cheap. 10 bucks is what we estimated in here. You want to go premium build, you can do the Raspberry Pi SD card. You can do a Raspberry Pi 4 instead of the 3, or even spend the money on a 5, which is a waste. You don't need that much horsepower. My recommendation, get the 0W if you're looking to buy a Pi. The Digirig or the Signal Link. This I won at a Hamfest, so it didn't cost me nothing. A better antenna, 25, 30 bucks, 50 bucks, 100 bucks, whatever you want to spend. Put your 2-meter antenna out there, or build one. Go check a video I got in our feed on building one out of coat hangers from Walmart. Very inexpensive. You can build an antenna for this thing easy. So, typical performances, urban environment with the stock antenna, 5 to 15 miles. Suburban area with an elevated antenna, 15 to 30. Rural elevated with good antenna, 30 to 50 miles. On a good day. Packet rates. Low activity area, you're going to see 10 to 15 packets an hour. Moderate activity, 500 or 50 to 200. And there was another packet coming in. High activity, 200 to 500 packets per hour. CPU usage on a Pi 3 or 4, you're looking at 5 to 15%. RAM usage, 50 to 100 megabytes. If you throw it on your network, it's minimal. It's kilobits per hour. Documentation, additional resources. Here's some documentation from Direwolf, APRS resources, a Raspberry Pi information, and of course, Ham Radio Playground. Check out our related videos. We did several videos on the UV-5R Minis. This is just one more in the series, right? And again, you can follow these steps and replace the radio with whatever radio you got. You just need the appropriate cables to connect to it and the appropriate settings for that radio. So, having issues, check the troubleshooting section. Leave a comment on this video. Join a discussion on ham radio program. I forgot to put it. Come on, Kevin. That's what happens when you get dry mouth. Check the discussions on Ham Radio Playground. Well, we haven't finished setting up that section on the website, but it is coming soon. There's a little nugget for you. Want to contribute? Yes, you do. Share your iGate experiences down in those comments. Submit any improvements or suggestions you have for this guide and help other viewers in the comments. Somebody's having a problem and you've got a solution? Throw a reply in there. Let them know how to solve it. Are you experiencing the same problem? Put a comment in there. If we're seeing multiple people with it, maybe we need to do a dedicated video to address that problem. And I'm more than happy to sit down with you guys again, play in this sandbox, and have fun. Changelog, don't worry about it. That's just us kind of keeping notes of what we've changed in the guide. License and disclaimer, yeah, okay. You need to be a valid ham radio operator if you're going to transmit. You want to receive only? No license needed. None. Zero. Make sure you follow all of the FCC regulations because you don't want to lose that valuable license. My disclaimer, no warranties are expressed or implied. I'm not selling you anything. It's a step-by-step guide. You're following the instructions. Test your own equipment within the accordance of its regulations. I am not responsible if you damage your equipment or you violate the law by transmitting without a license or any other regulatory violations. Don't come back and say this guy made me do it. Because not happening. That's it. Time for me to kick the sand off my feet. Hopefully you enjoyed this video. You found value in this video. Obviously, if you made it to the end of this extremely long video, you found value in it. If you think somebody else can find value in it, share this video with them. And most importantly, that's right, there's a few things that you can do. Give the thumbs up, say you like this video. And if you didn't like it, hit the thumbs down. I don't care. But if you hit that thumbs down, I expect a comment down below on what you thought we did wrong. If you are not a subscriber to this channel, what are you waiting for? Click that subscribe button. It costs you nothing, but sends the signals to Google, who owns YouTube, to say, hey, we like what this guy's doing. We want to see more of it. And then you'll get notified when we put out new videos for you to watch. And the super most important part, make sure you're having fun. Alrighty, I'm out of here. I gotta go to work. Done playing, off the playground. You've been booted. Get out, Kevin. Go, go, go. Till the next video.